Imagine stepping onto a plane, settling into your seat, and watching a massive machine weighing hundreds of thousands of pounds suddenly lift from the ground and rise gracefully into the sky. It's something we witness so often that we forget how impossible it should look. A flying metal tube, cruising at 35,000 feet, hauling luggage, passengers, fuel, and cargo, yet staying safely in the air for hours. But what stops it from simply falling? Today, we're pulling back the curtain on the science, engineering, and invisible forces that keep airplanes flying and make commercial aviation one of the safest forms of travel ever created. To understand why planes don't fall from the sky, we have to begin with the very heart of flight, the wing. Wings aren't just flat surfaces. They're carefully sculpted structures with a special shape called an airfoil. This shape allows air to travel faster over the top and slower underneath, creating a pressure difference that generates lift. Lift is the invisible upward force that pushes against the weight of the aircraft, preventing it from dropping to the ground. Without wings generating lift, planes would be nothing more than engines strapped to metal frames. Lift alone isn't enough, though. To keep generating that lift, a plane must stay in motion. That's where thrust comes in. The engines, whether they are turbofans, turbojets, or massive high-bypass engines, produce powerful forward force that pushes the aircraft through the air. Unlike a car engine, which only needs to combat friction and its own weight, a jet engine must push a heavy machine through the sky at hundreds of miles per hour. Thrust overcomes drag, which is the air's resistance. When thrust beats drag, the plane moves fast enough to create lift. And when lift beats weight, the plane rises. But even with lift and thrust, airplanes need stability. Otherwise, they would tilt, wobble, or roll uncontrollably. The tail section, known as the empennage, is designed to keep the aircraft steady. The vertical stabilizer keeps the plane from fishtailing left or right, while the horizontal stabilizer keeps the nose from pitching up or down. These structures don't just add balance. They actively fight disturbances like turbulence, crosswinds, and uneven pressure in the atmosphere. Without them, flying would feel like trying to balance a brick on a stick, impossible. Turbulence, despite being one of the most feared parts of flying, rarely threatens the structural safety of a plane. Modern aircraft are tested far beyond anything they will ever experience in real life. Wings are bent, twisted, and shaken until engineers find their absolute breaking point. In fact, wings can flex several meters upward without failing. What feels violent inside the cabin is simply the plane riding through changing air density. The aircraft is built to handle forces that humans inside may find uncomfortable, but that pose no real danger to the machine itself. Yet engineering alone doesn't explain why planes stay in the sky. Modern aviation relies on advanced computer systems that constantly measure, adjust, and optimize the aircraft's performance. Fly-by-wire systems translate pilot input into digital signals, allowing computers to smooth out commands and prevent dangerous movements. These systems can react faster than human reflexes and ensure that the aircraft stays balanced, coordinated, and safe, even in sudden wind shifts or challenging weather. But perhaps the most reassuring truth is this: airplanes are designed with layers of redundancy. No single failure is capable of bringing down a commercial aircraft. Every system, engines, hydraulics, electrical systems, and navigation, has backups, and sometimes backups for the backups. For example, commercial planes are engineered to fly safely on just one engine, even during takeoff. If one engine fails, pilots follow procedures to stabilize the aircraft and return to the nearest airport. The aircraft will still generate lift, still maintain control, and still fly. Even the fuel system is heavily protected. Planes carry multiple fuel tanks, interconnected lines, and pressure-controlled pumps that can reroute fuel instantly if needed. And if all power sources were to fail, which is incredibly rare, planes are still designed to glide. An airliner at cruising altitude can glide for around 100 miles or more without engine power. Far from dropping from the sky, the aircraft becomes an enormous glider, and pilots are trained to land safely even under complete power loss. Weather, one of the biggest concerns for passengers, rarely poses a threat thanks to meteorology, radar systems, and strict operational procedures. Pilots receive up-to-the-minute information on storms, winds, and atmospheric conditions. If a thunderstorm blocks the path, planes simply fly above, below, or around it. Modern weather radar sees disturbances miles ahead, giving crews time to avoid danger. Even lightning is mostly harmless. Planes are built to absorb and safely discharge strikes without damaging vital components. Another invisible guardian in the sky is the global system of air traffic control. At any moment, tens of thousands of planes share the same airspace. Without strict coordination, the skies would be chaos. Air traffic controllers track every aircraft's altitude, speed, and position using radar and satellite data. They maintain separation, create safe flight corridors, and ensure aircraft never come too close to one another. Modern systems like ADS-B broadcast planes' positions to other aircraft, reducing collision risks even further. The structure of airplanes is another marvel. While they look smooth and flawless, planes are built from materials that balance strength and flexibility: aluminum alloys, carbon fiber composites, and titanium. These materials can withstand incredible stress while remaining light enough for flight. Engineers simulate thousands of flight hours, pressure cycles, and temperature changes to ensure the fuselage can handle decades of expanding and contracting. Aging aircraft undergo rigorous inspections, where even the smallest crack is identified, tracked, and repaired long before it becomes an issue. Inside the cockpit, pilots undergo some of the most extensive training of any profession. They practice handling engine failures, severe turbulence, hydraulic loss, sensor malfunction, and crosswind landings, all inside full-motion simulators that mimic real conditions. Pilots must repeatedly demonstrate their ability to handle emergencies before they're allowed to operate commercial flights. Their training is built on the idea that even if several things go wrong at once, they must stay calm, evaluate the situation, and bring the aircraft down safely. So if planes are built to glide, packed with redundancy, stabilized by computer systems, guided by skilled pilots, and shaped by physics itself, how could they fall from the sky? The truth is, aviation accidents are the result of an extremely rare combination of factors. Mechanical failure alone is seldom enough. Pilot error alone is seldom enough. Weather alone is seldom enough. Only when several unlikely things line up at once does an incident occur, which is why investigations are so thorough. They aim to understand every small detail so future flights become even safer. This constant cycle of learning, improving, and innovating is why aviation has transformed into one of the safest industries on Earth. Each year, engineers refine wing designs, improve software reliability, and develop better materials. Modern aircraft like the Boeing 787 and Airbus A350 feature advanced aerodynamics, lightning-resistant structures, and fuel-efficient engines with improved fail-safes. As technology progresses, the odds of an accident, already extraordinarily low, continue to shrink. Image prompts. So the next time you feel turbulence or hear a strange noise mid-flight, remember this: airplanes don't stay in the sky by luck. They stay there because physics demands it, engineering ensures it, computers support it, pilots manage it, and entire systems around the world protect it. A plane doesn't fight the sky. It works with it, turning science into something that feels like magic. And thanks to the brilliant teamwork between nature and human innovation, planes don't fall from the sky. They soar. If you made it this far, thank you for listening. The world is full of silent stories, waiting to be explained. Subscribe, and I'll tell you the next one.